There's a few slides we've been asked to address right up front. So of course, the PSConf Asia, all the hashtags, thanks to all the sponsors, all the normal conference situation, and the docs.microsoft.com. If you guys, or docs.microsoft it is now, if you guys haven't seen this stuff, you definitely should go check it out. It's a great learning great system for learning new stuff. And of course, Microsoft Tech, big sponsor of the event. Obviously, we're here in their offices today. Microsoft loves geeks, and so, yeah, join the conversation. But now we're going to get started talking about my stuff. Basically, we're going to go, I kicked off, hope you don't mind, yeah? We're going to talk about taking a relatively small or relatively large, depending on where you're coming from, but taking an organization from 100 deployments a day through to very, very fast delivery of software towards our customers. And what does it take? So what business processes needed to change? If you guys are looking for Yarp and his session, it's next door. We've swapped rooms for this one. So yeah, bit of a different topic. Who am I? I haven't spoken to, I think, any of you guys before, so I want to tell you a little bit more about myself. I'm a development manager at Coolblue. I've been coding since VB6 was a thing, which kind of shows off my age a bit, but also my experience. Up mentioning that a shell was a language that's available in the Azure functions now actually excited me. That's cool. Father, husband. I'm based in the Netherlands. I'm working with Matt. You can see the session in a few hours. And if you want to hit me up on Twitter, if you've got if there's anything I can do for you, my handle's there as well. So, before I get started about, straight into the CI/CD process, I want to address when I'm talking about this sort of topic. Yeah, you okay? Can you hear it? Okay, no worries. Sorry about that, guys. So I want to rewind a bit, talk about a few of the questions that I commonly get after I've delivered this presentation, address them right up the front. And that's the biggest one is why 1,000 plus, or why do I want this many deployments a day? All right. The short answer is I don't know why you want this. I don't know why this is important for you. What I can tell you is the standard IT answers. And I can say that for us, or for you guys especially, if you don't need what I'm going to do today, or you don't need a process, or you're not operating at this scale, please, you ain't going to need it, or keep it simple, right? Keep it simple until it doesn't work anymore. That's basically my recommendation for you guys. But, as I said, I'm working at Coolblue. Coolblue does need us to work at this sort of scale. We have a large number of colleagues now. This is a graph of our growth that I'm allowed to publicly share, which is very exciting. You can see that, yeah, we were growing like any normal company until about the time I joined. That's just the joke that I enjoy making. Correlation, causation, it's a bit funny. I'm obviously a member of the development department, being a development manager, but the department started really quite small. Especially back when I joined Coolblue, I think there were about 40 odd people in tech. Over that period of time, though, we've doubled and doubled and doubled and doubled. Seems like every 18 months or so, we've doubled in size. And that goes along in line with our revenues as well, which is, I think understandable. This is obviously Dutch. I'll translate it, directly translated for you. It says anything for a smile, or everything for a smile. And this is basically what drives all of us. We are, for those of you that don't know, we are a e-commerce online and offline retailer based in the Netherlands or the Benelux region with a obsessive focus on customer satisfaction. All right, so you can think of us like a very localized Amazon, but trying to make our customers a lot happier. Okay. The other question I normally get is, so I've got a CI/CD process, or let me ask the question to you guys. How many of you have a working continuous integration or continuous delivery system at your current job? Yeah, a few. Nice, okay. And so what's the difference between pushing out 10 deployments a day, a week, or a month, and 1,000 or 10,000? Or if you've seen Donovan Brown present and you're talking about millions of deployments, that's obviously a different scale again, and they have different learnings than I do to share with you today. But I want to take it back to some of the theory, like some of the really classical theory. This is a paper that was published in 1969, 1970 from memory, from a Dutch correlation there. And you can read about it here, but there's one quote basically that I want to pull out of this paper. It's a really cool paper. It's got a lot of stuff in there. I'll let you guys read it, of course, but the key part here is we tell ourselves that what we do once, we can do twice, and by induction, therefore, we fool ourselves into believing that we can do as we need, okay? So 10, 1,000, 10,000, what's the big difference? He goes on, though, the part that I love most about this quote, to compare a child that can crawl with a jet plane that can fly. In terms of moving, they can both move, but they both travel at very, very different speeds. All right? And I think that's the same for us, or the stories that I'm going to tell you today. We started, and you can see the growth, and what worked for us down here, as a child that could crawl, doesn't work when you get to jet plane speeds, right? Or maybe not jet plane speeds, maybe that's a few years still to come, but it doesn't work when you start getting significantly faster, or significantly bigger, or scale significantly more. Obviously, the title that I showed you guys at the start was from 100 to 1,000 plus deployments a day. What got us to 100? For those of you that have working integration pipelines, this stuff's pretty straightforward, but it's worth reiterating some of the common building blocks that we've used to get there, which is basically this checklist. Sat down with a friend of mine a little while ago, and we tried to distill it down into as few checklists as possible. But basically, we have really good standardization within our organization already in these areas. And so if you guys are looking for what do I need to get the pipeline up and running, what do I need, what business processes, what things do I need to train myself or my peers on, I would advocate any of these if you don't have them already. All right. Like I said, at Coolblue, we're very lucky. We have a lot of this already handled. A lot of this is already done. And we love this. Right? Developers that come in and watch the standardization or look at the standardization we have and look at the high bar that we have for things like code quality or short-lived branches or analysis, infrastructure as code, and our CI/CD pipeline, the main topic of today. Yeah, we think that this is already quite nice and already quite stable. So today is not about automated testing. Today is not even really, I've got a story about PowerShell, but it's not even really about PowerShell itself. It's basically what of these have we got that we needed to end. All right, so now stories. Entertain you, that's all the boring stuff. Now I just want to tell you 4 stories, right? And the 4 stories are on these 4 topics, right? We have responsibility, autonomy, ownership, and failure. And for me, these were the 4 big things that I watched and helped and participated in the change to take us to the next level, okay? We'll start with responsibility, and I want to talk about a hub and spoke model. Have any, you guys understand what I'm talking about when I say a hub and spoke? So we've got a central, I'll explain it in a minute, basically. We have a hub, or we had a hub, or we still have a hub, depending on who you ask. And that was our DevOps team. How many of you have a DevOps team? Yeah, or a hosting and deployment team, or an infra team, or a system support team. I've heard it called many, many different things. But basically, we had this team. And this worked great when it was only a few developers, right? When it was 3 or 4 developers, 3 or 4 teams of developers, relying on this one central team to help us get machines and pipelines and build infrastructure up and running. That was fine. But then we started adding more teams, obviously. Like I said, we were growing very aggressively. And so as a result, those guys weren't always available, and you started these informal connections between teams, right? So you started seeing more and more messages like, hey, has anyone done this before? Who of my peers can come and help me with that, right? So instead of going through the official channels, it was, you just need to make this shortcut here or add this file to this repo here. And so you saw a lot more informal learning. And obviously, as we grew and as more and more teams got added on, these informal pathways increased as well. All right. I see a few of you nodding. It's good that this wasn't just our experience as well. What it looked like, though, was the central team was getting very, very overloaded. All these teams have a direct official dependency on the hosting and deployment team in our case, or the DevOps team. And so in the future, these guys just were going to have a crazy, crazy backlog and not being able to satisfy any of the developers in a timely manner. So instead, what we've done, and what we're doing at the moment, is we're making all these connections informal. Right? We're taking the responsibility or the direct tie-in from the hosting and deployment team and the infrastructure team and making a lot more stuff self-service. All right? These guys, and I would say this is where we are at the moment, these guys are still a very central part of our organization. They're still some people call these centers of excellence or the gurus, right? They're sitting in those teams with all the other development teams able to go to them. And you can see that and we want to move to more of a structure like this where the hosting and deployment team is just another team, right? You've got enough information, enough responsibility, enough self-service that the rest of the teams can operate without having to go necessarily and talk to the gurus or the center of excellence people, right? And you can do that via knowledge sharing like we've done. You can do it via automation, which some of the stories I'll talk about next go into. But basically, I think this is the biggest thing that we had to change. We had to remove that central hub. You can see that here. These are some snapshots of our Slack channels from a few weeks ago. We have 220 people in our development chat at the moment. That's not all developers, but it's also, yeah, some developers are missing. So it's my job to probably figure out where those guys are. And of those, we've got 139 of them in the deployment superhero channel. So instead of being where all the teams would come to ask questions of the hosting and deployment team or our DevOps team, now it's a lot more peer support. And I know I've blurred it out. I had to because obviously we're talking about infrastructure stuff. But you can see here that it's a lot of people helping each other. It's not one question, one answer. You see a lot more collaboration these days, which is a massive improvement. The other way that we notice this and the other way that we enjoy showing it off is via the self-service stuff that I was talking about as well and the knowledge. And this is a developer or a development team lead talking with the team lead of the hosting and deployment team and trying to get a new piece of infrastructure up and running. I should mention that we're on AWS, we're not on Azure, so you'll see some AWS specific references. So adding, this is the CloudFormation file that was required to add a new application into our production environment. The team lead of the team that was developing that solution, the proposed CloudFormation changes himself. And then Sander, the team lead of the deployment team or the hosting deployment team, came in as a center of excellence person or as a very knowledgeable person and said, oh, by the way, if you remove this line, you probably don't need this one. It can fall back and we'll use the more generic rules instead of you being specific. So this is a good example of the team lead making a request. The team lead of the team that would have previously been responsible for that, approving it, having a look over it, making sure that it's fine. But the most important part here is this, and I don't know if this, yeah, it works. This little green box here and down here. And that shows us that our linter, which is part of the automation that we have, which was a few slides back, that linter is actually doing its job and making sure that the team lead of the team that isn't necessarily the most knowledgeable in this area has proposed changes that will be accepted into our production environment. Okay, so one of the hosting and deployment team's responsibilities was moving the stuff that they would commonly fix or the stuff that people needed to rely on into that linter, so the linter and the automated processes could pick all that up instead. Okay, so you no longer need a human to go have a look through the pull request and make sure you haven't done something silly. The linter will just reject that. I've got another example as well from a developer. This one is a little bit more recent. He's trying to add Dynamo to his, because he decided he needed storage. Yeah, we've got the linter, it's run. We've had Team City, which I'll talk about tomorrow. I've got a talk tomorrow that's a little bit more focused on the actual pieces. But yeah, Team City ran in a very, very short period of time and said, yeah, this looks fine. This code is ready to go, right? So someone else, another developer, approved these changes. The original developer merged the commit, and then all of a sudden we have new functionality available in production. And this is literally, I know that it's days ago, so you can't tell the actual times, but this was under an hour from, hey, we need storage. Hey, wait a minute, in our production environment, we now have storage. And it's already been approved, it's been linted, it's been verified, and no one from that hub now needed to be involved, which was great for us. So that's abdicating or dividing or sharing responsibility. That was one thing that really needed to change for us. All right, but next I want to talk about autonomy. And some people see these as I don't know, not complementary, right? Some people see them as, what do you call that? Opposites, right? Giving responsibility and autonomy to a team is, I can tell you from personal experience, is sometimes quite difficult. And for this, I want to talk about our application structure, right? So the story that I have for you for that one, for this, the example that I have for this story is our application landscape. We have a whole bunch of applications at Coolblue. Like I said, we're a big e-commerce retailer. There's a lot of stuff that goes on behind the scenes of a large retailer that actually goes from placing an order on the website through to you receiving a package at the door, all right? Each of these logos, these are the logos from our internal systems. Each of these logos is a completely separate system. And I'm going to talk about a lot of the smaller ones first, all right? I'll come back to Vanessa Optima Prime, our main application in the middle there. A lot of our smaller applications, a lot of the smaller logos on the previous page, doesn't necessarily mean they're smaller apps, have all sorts of logging and monitoring, right? From a development point of view, we've got Serilog. If you guys don't recognize the logos, we've got Serilog and Sec, or SEQ, depending on how you want to pronounce this, to enable you to develop locally and verify that it's doing what you want it to do. And in our cloud environment, we have Splunk and Datadog as well. And those guys, using the structured logging, right, it's very easy for us to build things like dashboards. And this is a real-time, this is an example of a real-time orders dashboard where we can see the orders flow straight past, right? This refreshes fairly fast, and there's a fair number of orders coming in. This is under a minute. Yeah, about a minute and a half worth of orders through on just a random day, all right? There's nothing special here. You'll notice some oranges. There's no reds. Thankfully, I was able to find a moment where there's no reds. But these oranges are basically pending because of timeouts. That can be things like your bank is taking a long time to respond, and so we'll take on the risk ourselves, or maybe we need to do some double checks on the order itself, all right? So for us, adding the structured logging to our C# and to our other applications, our internal applications, meant that we can build these dashboards really, really quickly. For an example, if you want to dive in as well, if you're using the structured logging in your .NET apps and Serilog specifically, you can dive into you grab the order ID for one of those orange ones, you want to figure out what's going wrong, and you can see here that we're tracking it across multiple systems as well. So we've got our web shop, goes into the order synchronization service, and then goes into the CRM service. That's basically, okay, the CRM service has a problem with this order, right? It's very quick and easy for us to find this stuff. It's also very easy for our security team to add on to that. Our security team features a few times in this presentation, actually. But our security team jumps on those logs as well. Without the developers having to do anything, they can use the same logs that are streaming into those cloud systems to build their own dashboards. And this one is specifically about what traffic is encrypted and what's not. So this is all without the developer having to do anything. A business analyst made the original dashboards, and then a different business analyst, or maybe someone from the finance team, is tracking down what's related to specific orders. And now the security team, you can see all these guys are using this single stream of information that's coming from the C# apps. And we use data, so that was Splunk. We also use Datadog to keep track of, is the web shop up and all those sorts of metrics as well. And so everyone's happy. That's great. We've got a really good story there. It's really solid. But now I'm going to go back and talk about Vanessa Optima Prime. All right, we have this much larger application, and it's big. It's written in Delphi. It's a few million lines of code. It's a little bit scary. And being in Delphi, well, yeah, before I get back to the revenue, being in Delphi, it means that a lot of these things are a lot harder. Okay? Vanessa Optima Prime, to give you an idea, started back here somewhere, much, much earlier on in the pipeline, and has grown along with the rest of us, whereas a lot of those C# apps, a lot of the more modern stuff, was started probably around this area and are now nice and stable. So being this old and being so big, it's grown, all right? It started looking something like this with a few menu options and a few buttons, and it's grown to quite a big beast, all right? So we were given the problem there, the challenge there. Okay, how do you take a very maybe legacy, maybe a very important application and push those logs into the same tools so that we get the same sorts of benefits out of those tools? And for the team that was implementing this, they thought, that's easy. We'll add a collector. In Delphi, we can also use the same sort of structured logging. We'll push that stuff into a collector, and then we'll stream it off into those online tools, right? The cloud-based software as a service. The challenge is that each of those collectors, and I think this is common across a lot of these sorts of tools, each of those collectors costs money. So all of a sudden, that's a problem for us, all right? We have Vanessa Optima Prime running on many thousands of workstations times a small value for the per collector cost just meant that that's infeasible for the cost-benefit analysis. So they went back and they thought about this for a while, and they went, I know, we'll add one big sink, right? We'll put it on one big common machine, or we'll put it in a cloud environment somewhere. We'll put one big sink there. This is going to be great. UDP traffic just flying at it. These collectors can handle a lot of stuff, so no worries. This should be fine. And then I told you security would feature a few times. Security came in and went UDP in a production environment, random traffic flying in from everywhere, structured logs, weird JSON packets and stuff. Yeah, this sounds good for you developer folk, but for us, not so much, all right? So then that failed. But security was happy. I put that slide in just to please you, Anthony. I know it's being live streamed back home. So the team went back home and went back to their room, thought about this a little bit longer, and said, I know, we'll put that big collector into the cloud infinite scale. Everyone's heard all the sorts of, amazing stuff. It only costs you a small amount of money. And we'll make it run TCP, because the big complaint was UDP traffic is very hard to monitor, very hard to control where it comes from. You can't attach security to it. So that worked well until it didn't. So I said before, we've got many thousands of instances of this application running in different pieces of the business, and they very, very quickly overloaded a TCP sink. Now at this point, you can go, okay, you know what? I'll find a way to shard these guys, and all the people from this environment will log to that one, from that environment, and all these sorts of different challenges. You can find ways to make this work, please don't get me wrong. But instead, there's got to be a better way, right? Instead of just, okay, this half of this warehouse will log to that collector, and then putting all that sort of logic into the app, that gets a bit scary. So they went back and they thought about this, and they said, I know, the cloud is a good thing. We'll do this differently. So they pushed all their logs into the API gateway. Like I said, there's going to be a few AWS references that'll make a few people happy here. API gateway, push that into a Lambda, push that into CloudWatch, and then the collector can actually pull it out of CloudWatch, which is AWS's log metric aggregator. The problem is that even that was too high thoroughfare, but it was actually quite easy now, because now we can put Kinesis, which is a AWS-specific log metric aggregator, into the middle, and then hand it off to Lambda, which will log to CloudWatch, which the collector can pick up from. And that's working quite well. All right, this is a relatively new story that I'm telling. I only added these slides last week, the week before. These are the stats that we've got recently from an internal application, Delphi application, using the same tooling, pushing through that collector. You can see they turned it on early September-ish, and we're getting a large number of requests. This is for each button press, for each form rendered, that sort of stuff, so that we can track hotspots through the application. So now everyone's happy, and that was cool. And of course, because I'm a development manager, not a developer, it's my job to buy beer and get high fives. So that was basically the trade-off that I had there. And that was how the team was autonomous enough to make those decisions, those mistakes, those learning opportunities all the way along, all right? You saw that they had a UDP sync, they had their own configuration in the cloud. From the responsibility story, you can see that they were able to make those changes themselves, as long as it fit into the production environment. But it gave them the time and space to figure out the right solution to that problem for themselves, okay? It's a good example in my mind of autonomy and the autonomy that a team needs to have that's separate from the rest of the organization. In that example, you saw that security came in at one point and said, no, please don't do that. But overall, no one else was sitting out going, this is what your solution needs to look like. There was no more dictation onto what specific cookie cutter pieces of the cloud environment they could use, which was quite beneficial for them. Autonomy and ownership, in my mind, are very closely related, because if you're autonomous enough to make your own decisions, you can then quite happily own those same decisions. But instead, I want to talk about one of the best contracts we've got. And I said PowerShell would feature. This is basically the story that I have based around PowerShell. Unfortunately, there won't be any demos or anything, but it's a good story, I think, nonetheless. We've got a contract. Right? And not necessarily a written contract and signed like this, but it's more like this. Right? Our build system is TeamCity, and in TeamCity there were many, many, many different build configurations, and they had things like run NuGet fetches. How many of you are like .NET developers or PowerShell devs, use NuGet? Yeah, there's a few hands. Nice, okay. So this isn't completely foreign to you. We're fetching packages from NuGet, we're building the solution, we're running XUnit to test it, and then we're going to create some NuGet packages and publish it. And this is all inside TeamCity. This is in our build runner, because that's where you put things, right? Especially when you're small and you're getting started, you're like, yeah, I just need to add a few steps here. Unfortunately, it doesn't scale. But once you get to a certain relatively large number of applications, relatively large number of configurations, this just doesn't work anymore. So what we did is we stepped back from this and we said, okay, what type of contract, what sort of expectations do we have on the development teams? And we made some standardized pipelines. Right? This now allows us to say, all these steps are generic, and this is what you probably should be doing unless you need to customize it yourself, which allowed us to scale faster. Right? If you saw Jeffrey's talk this morning about standardization and automation, this is where that ties in. Right? This was the decision that we needed to make about build versus buy. This is where we needed to make those same decisions that he was talking about this morning in his keynote. And so for us, we said, well, it can be even one step better than just a template and us handing you a template, right? How about we just make it so that TeamCity calls build PS1. And every single one of you development teams, you figure out what your build PS1 is supposed to look like, and we'll run that for you, and so long as it returns a positive result, we'll go off. It's literally, this is the only step in our pull request, in our build release pipeline now, all right? We will call build PS1. This was the hosting and deployment team that I was talking about in the first story. The hosting and deployment team said, we'll configure TeamCity so that it looks for a build PS1, and then you guys can figure out what it is you actually want it to do, all right? And that enables some great stuff for us. It enables developers to make all sorts of decisions. We're a very big, or my focus, my background is .NET. We've got a lot of .NET applications, so these are .NET specific examples, and some Delphi examples as well. But we've got Cake, Cake Build, PowerShell and PowerShell Core. We all know those logos at least. Flyway as well for our database configuration stuff. All these, the development team can now choose what to use when, or if they even want to use this one. We were experimenting with Nuke for a while without any sort of impact. It also allows, on the other side, the hosting and deployment team, or the team that's responsible for our infrastructure, to make their own choices as well. All right? So like I said, TeamCity is where we've got everything at the moment. It's where we've had everything since long before I was there. We've added Scrutinizer, and we're experimenting with AppVeyor, for those of you that don't recognize the rest of these logos. And one of the common questions I get is like, yeah, but where's Azure DevOps, or where's AWS's Code Deploy, or CodeStar tooling? And those are good questions, but I don't have the answer to them right now. Okay, this is where we started, this is where we've grown to, this is the separation that's enabled us to make the decision about who's going to own what. And in fact, this is a really good example. When I went into AppVeyor to get the logo and logged in using my Coolblue account, I realized, wait a minute, there's already some builds in here. And some of those guys from the infrastructure side of things had actually gone in and experimented with, does anyone even notice if we change the tool that's running, right? I can tell you now the answer is no. So long as it calls build PS1 and reports the status back to GitHub, we actually don't know or don't care where it runs, right, from a development point of view. And from an infrastructure point of view, they don't care what it's building and what it's running, so long as it calls build PS1 and exits with a successful error, right? Or exits with a successful exit code. All right. So this was actually quite surprising for me to see this sort of autonomy as well, and ownership. So then, next. All right, this is the Azure DevOps. Have any of you guys used any of these? You recognize the logos? A few of you, yeah, lots of nodding, nice, good. So we've got, yeah, the new Azure DevOps logo, DevOps Pipelines logo, Kubernetes Docker, sorry? No. The AWS Code Deploy, I think that's the Code Deploy logo. Their logos are so confusing to me still. I don't know what's next, right? Even as a development manager, even as someone that's sitting, in a position to know what comes next, I don't know what comes next. That doesn't faze me, right? I don't care. So long as these guys own whatever it is that they're choosing to roll out next, that's what's important to me. Right? And I think that's what's important to get us to the next level. If we find out now that TeamCity doesn't scale the same way that the revenue numbers have, the same way that the teams have, yeah, okay, let's change it out. You guys have the ownership. We have a contract well-defined that a build PS1 will be called. So we'll call the build PS1 and everything will continue working. Yeah, so long as we've got build PS1, so long as you've got that PowerShell file in your repo. And I can show you that I've actually got a session tomorrow where I go a little bit deeper into what the build PS1 actually is and what it contains and what we use. So if you want more information on that, if you have questions about that, come see me tomorrow. But that's basically my story about ownership. The change in the mindset of our tech department, our software development, our software developers, to enable them to own the application, all right, to enable us to scale. And now my favorite part. This is my favorite story. I love talking about failure. How many of you have read this book? Any? None? Okay. If I can give you one recommendation, if you're looking to if you're part of a growing organization, or if you're part of, if you want to start experimenting with failure and having a positive mindset, things like blameless postmortems, things like, yeah, failing forward, please check this book out, give it a read. I know it's really quite old. It's not got any modern references in it, but I do think that the lessons learned will translate very, very cleanly into even cloud environments today, all right? The key quote that I got out of this book was fail early, fail often, but most importantly, fail forward, okay? Like I said, we're an online retailer. For those of you that were in Yarp's session before, he made some jokes about us having to know when things are down. This is what our error page looks like. It basically says, oops, we're running to our keyboards. We will get this back up for you, and then please just reload the page or talk to us on Twitter or Facebook if it's not fixed quick enough, okay? We have a few different variants of this page, but it all basically comes back to the same thing. Hopefully, we will know about this. We even have a version for our mobile app, which is this pretty. So the pressure's on you guys. I'm talking to those guys. I know they're watching. So the pressure's on them to make this look a little bit prettier than this when the website fails. But hopefully we know that the website's failing even before the page is finished rendering with you guys. All right? Normally I'm delivering this talk to a Dutch audience, so I can make some sort of joke about we'll get there faster than the page will. But that's, it works less here in Asia because your internet's actually quite stable and nice. It's not that fast, but it's stable, it's good. Yeah, we will know, all right? We have a lot of logging, monitoring, alerting. This was the job I was making, right? We don't need to monitor Twitter using Microsoft Flow in his example to figure out sentiment and then send that off to a branding team to send that off to our tech team to figure out that the website's down, all right? We will know. But that part's boring, all right? That's a standard story of website uptime, website downtime, SLIs, SLOs, SLAs, all that sort of stuff that Stephen, if you guys saw Stephen's session this morning, all the stuff he was talking about, we've got all that. All these dotted lines and norms and variances, all this sort of stuff, that's working fine, all right? So a lot of what he was saying this morning for us, I can tell you, yeah, it's perfect, right? He's spot on the mark there. Instead, what I want to do is I want to tell you a story about our delivery service. So in the Netherlands, we have a national postal service, all right, which handles parcels to a certain size. But we also have a whole bunch of external people, right? You can think of TNT, you can think of these delivery proposition, the people that are able to deliver larger items like washing machines or fridges, those sorts of things into your house, right? And it normally involves, from a retailer point of view, handing that stuff off to a external third party and saying, well, it'll be with you when they get to your house, right? That wasn't good enough for us because, like I said right at the start, we're obsessed with the customer experience that someone has. We want to know that if you buy something from Coolblue, that you will get it the next day because that's one of our biggest propositions. And so when our friends, our partners, the delivery partners, weren't able to do that, experimenting with doing it ourselves. So the story that I've got today is about monitoring and watching and fixing failures in this sort of a system. All right, so a little bit different for a website. That being said, we still have lots and lots of dashboarding. We still have norms. We have our accepted error rates. We have a large number of errors going on in this snapshot. You can see that a lot of our durations and all those sorts of SLIs and SLOs are fine. They're set. Everyone's happy, except for this little bit down here. So I'll just stand here. I can't block it, but mostly everything's fine. All right. But we also need to accept and process and deal with fault, with error, with failures. These things will happen. We're talking about large washing machines, big American fridges, right? You know, trying to get them into small Dutch houses, that can be quite complex. So this is the example that one of the best examples I've got for you. At 7 o'clock, at 5 o'clock on a Friday, stuff started happening. I can guarantee you, I can't guarantee you, but I can maybe provide you a scenario where at 5 o'clock on a Friday, where your working week is Monday through Friday, someone probably went, yeah, this'll do, right? I'll pick this up again on Monday, and then pushed, and then everything worked until it didn't. So very, very quickly, a whole bunch of stuff started popping up in Slack, right? There are shipments that are failing. There are all sorts of errors that are coming up. Our OC, so this is our operations center, or our technical support hub, our whatever you guys call it in your environment, basically said, hey, by the way, we're seeing a lot of things turn red. Can you guys come help us? And this was 10 minutes later, right? This is 17:09 now. So this is exactly 10 minutes after the health dashboard went red because there's a 10-minute delay to make sure that the OC doesn't get, or our operations center doesn't get swamped when things flicker red while there's deployments going on and that sort of stuff. So instead, they got the delay, they got the message exactly 10 minutes later and alerted the development team. And then you can see exactly 11 minutes after that, and that time's not a joke either, that everything started going green again. Right? So you start asking yourself, well, there's no response here. At least I didn't show you a response. You'll have to trust me. There's no response here. What actually happened? And that's because one of our leads, Steph, the same guy whose pull request I showed you before, went into our production environment and said, you know what, I'm just going to terminate these unhealthy instances, right? Now, thankfully, he was able to see that in the background, his deployment wasn't successful, or there was the instances were stuck in a weird state, so we were under capacity, we were not able to supply. The short answer was, let's just terminate those instances, right? It's 20 passed, and then again 31 passed because he found a second one that was unhealthy. Basically, get rid of the unhealthy instance, right? And straight away, this is 520, 521, everything started going green again, all right? fits perfectly into the timeline, but he didn't need to redeploy anything. He didn't need to change anything. He didn't even need to, he could have he could have left these, and then our monitoring system that's looking for unhealthy instances would have picked up later on that it was unhealthy, but we're starting to head into prime time for online shopping, so you want to make sure that everything's green for that sort of time period. So he just went in and short-circuited that and said, yeah, okay, I'm going to terminate it. The interesting thing here is that, yeah, we've got all sorts of Slack connections. You can see this now because this obviously isn't his face. But we have a level of accountability that he has as well, because this now reports to nearly 200 people that Steph, this individual over in that team, terminated some instances. And we don't care that it's Steph, so for you guys that were at Stephen's talk and he was talking about blameless postmortems, and he was talking about, you should be talking about infrastructure or process, not necessarily the people that did it. We do put the name in there, but that's just so that we can ask that person, okay, why did you have to do this? And that's basically the follow-up here, where we link to a Google form, which I'll show you in a second, to say, please fill out an RFO that explains to us why you needed to do this. Not why you needed to do this, but why was this, what process failed that led you to making this decision, okay? Very, very different than, hey, Steph, what's wrong with you? Why'd you press that button, okay? Very different angle. Same sort of message, which is why I need to make that clarification, but a very different angle. And Steph put in here, yeah, done, right? So the OC itself can then go back into the development channel and go, okay, yeah, and Steph submitted the RFO for this. A funnier story that I think I have time for. We have Coolblue bike delivery, all right? This is literally a bike with a big bucket on the front that we put parcels into, and then we go get it to the person's house. Because, like I said, we want customers to be happy. What's better than placing an order, 2 hours later, your doorbell ringing, by the way, here's the product you wanted, right? It's awesome. The Netherlands is quite small. To give you guys some context, relatively speaking, the Netherlands is quite small, and a lot of people had grouped in a few key areas together. So this is actually technically possible, and the bicycle infrastructure there is amazing as well. So all that adds up to making sure that this is possible. So yeah, we load packages into here, and we take them out. Now take note, when we kicked off this process, we said this bucket's 20 cubic centimeters, right? We only want to take relatively small parcels because we're just experimenting. We just want to take, like, if you order a HDMI cable, no worries, can we get that to your house really quick, right? And everyone was happy. We kicked it off, massive success, right? Everyone's, wow, this is cool. So then we went, okay, cool, the system's working. Let's make it so we can ship some more stuff this way as well, right? So the logical step is you increase the size of the bucket. You say this is 50 cubic centimeters now. And this Philips Senseo machine, any of you guys have Senseo machines? A few. This Philips Senseo machine is exactly 49 cubic centimeters. Perfect, fits in the box. Goes right in the bike, goes off to someone's house. Your coffee machine breaks in the morning, you can have a new one before lunch. Easy. Except, Philips decided that, hey, we've got this new milk frother, right? That's why I asked if any of you guys had Senseo machines. Philips basically said, we're releasing a new version of our milk frother, and we want to give it away to the first 15,000 people that order another Senseo machine, right? But it was just a free add-on. It wasn't any sort of, hey, this product plus this. It was just, it happens to be in the box. And we changed the box, by the way, we changed the box a little bit, but don't worry about that. So you put these two together, and unfortunately, this isn't 49 cubic centimeters anymore, at all right? This is quite a bit larger, which confused the hell out of these delivery drivers, right? Because all of a sudden, they're getting a box that's supposed to fit in the mouth of the bike. You can see roughly the size, right? It doesn't fit in anymore, right? Especially doesn't fit in with other boxes next to it. And so that made them very sad. And this very, very quickly rippled through the whole environment. Yeah, I'm running a bit over. I know, I'm sorry. So the whole fleet all of a sudden got very sad. The easiest thing the deployment team did was change the size of the bucket back, all right? We went from 20 cc's to 20 cubic centimeters to 50 cubic centimeters. We changed that back, deploy a change into our environment to change that back to 45, not to 20, right? So this is a whole new feature request, new process, all that sort of development process that goes into making a change, and we changed it We failed forward by changing the size back down, which then excluded that Philips Senseo machine, and then these guys were happy again. Yay. Like I said, Steph before needed to have a RFO filled in. This is basically what the RFO looks like. I'm going to skip through a few of these slides because they're less relevant to this, this talk, but I'll make them available if you guys want to look them up again later. We have the RFO meeting where we discuss these, like Stephen was saying again this morning about the making sure you have blameless postmortems. I link a slide right at the end for Kathleen Dollard. She has a whole series of documentation on how to do those. Please check that out. But this is a once a month thing, right? So what do you do when the world's on fire? For an e-commerce retailer, it's quite important that we address things in a pretty timely manner. We don't need to wait 18 days to figure out the website's down, right? Or why it happened, because it can probably happen a few times. And so for that, we've got Slack, we've got War Room, where people are constantly doing Kathleen Dollard's debugging game, to which I'll link at the end. Sorry, I don't have time to explain that now. But yeah. They use that game to rule out what it could be and fail forward in that regard. You can see here an example where we've got a whole bunch of people ruling a bunch of stuff out. Then the OC, our operations center guys, coming in and saying, don't worry, everything's looking green. We're going to close the war room now. And then everyone bails. All right? Very important for us that once we rectify something, yeah, you don't need to be there anymore. Okay? So those are the 4 stories that I had. Hopefully it gives you some ideas, some inspiration, some takeaways for your organization. Different people are in different industries and all sorts of different environments, I know, so that's a little bit challenging, but if you've got any questions as well, you can come see me later. The 100 to 1,000 checklist, so this is looking back on this process, using the 4 stories, using the stuff that we've gone through today. I wanted to make a matching checklist for the 16 checkboxes I showed you at the start. This is another 16 checkboxes. And if you can answer all these, then I think you're going to be in a very, very good position. All right? I'll tweet out a link to the slides after. But yeah, this dashboard is basically a recap or a summary of everything that we needed to do to enable us to scale, to keep up with the demand. So unfortunately, we're out of time for questions. I do have the checklists in the slide deck. So that's this one, the how to get started and what you need to do as a development team. This one, what you need to do to make that even better. And then I've got a link in here, like I said, to the debugging game. If you guys are doing things like postmortems, you're doing things like war rooms or outage investigation, that sort of stuff, you should check this out as well. Okay, thanks. Oh, I do? Okay. If you guys, do you guys have any questions? No? No worries. If you do, yeah?
So you talked about the logging and making sure that it went through UDP and TCP and all that.
Yep.
But how much time did it take to get to that solution? And was there a limit to get to that solution quicker? Any pressure that was pressure?
Yeah, so I think that team, we spoke, that was in the section of autonomy, right? The team was able to make those decisions themselves. They had their own pressure because this is something this is a feature they needed to deliver. This is a request that they had from the business. So there was the opportunity there, or there was the pressure there to get the story done, right? In terms of the time that it took, I believe it only took, once they'd decided on the final outcome, it only took like a day to get it live and out, right? It's not necessarily the time that it took to deliver that solution, it was just the feedback cycle was very, very quick. I believe it only took them 2 sprints to go through that whole story that I told you, which is about a month at Coolblue. So we.
Just around, the
Yeah, the hub and spoke stuff. Yeah.
I mean, normally centralized for control and security
Mm-hmm.
reasons. Once you start decentralizing, how do you keep that control and security devices?
Yeah, so I think that's a great question. The question was, when you go from a centralized team into a decentralized team, it's normally centralized for a reason: security, auditing, all those sorts of processes. I would say that a lot of those, like 99% of those, can be handled automatically through automation. I gave the example of the linter. That linter is not just checking that your syntax is correct, right? We've added our own tool set, our own responsibilities, our own do nots, right, into that linter. And so that linter can tell whether you're exposing a instance in our cloud environment to the public internet, right, and then just deny your pull request. So there's a lot of accountability there and a lot of responsibility taken away from the individuals, the humans that would have scanned that, like the security team, and put into automated tooling. And then using things like GitHub's gated check-ins, using things like pull request building, that sort of stuff. There's also a lot of accountability there as well, and auditability and traceability. So a lot of those concerns are handled by more automation. And I think that was, in the keynote this morning, Jeffrey Snover was talking about automate everything that you can, and he had two different reasons for automating things. I think that reason is much more on the right. So that's automating for control, automating for speed improvements, whereas the story that I told today was maybe a bit more the automating on the left, automating so that you can make this faster, so that you can make this scale. So our developers want to get stuff into production quick. Let's automate that so that they can, right? Whereas for auditing and security and that sort of purpose, yeah, we're also auditing because we're doing exactly the same piece of work, but it satisfies that criteria as well. Does that answer the question? Nice. Great. Thanks, guys. Oh, and of course, I needed to put this one at the end. Don't forget,